Welcome back, pre-calc. Here is section 5.2, example number 3. For this one, I've got a fraction on the left-hand side, and I see 1 minus cosine x underneath it in the denominator. So if anytime I'm in a fraction, I'm going to try working with those guys first. So for this one, we are going to multiply by our conjugate. We talked about conjugates in the last example. Remember, your conjugate has the same first term, same last term. Only thing different is this middle sign. The sign in between them needs to be flipped. All right. So multiplying the top, I'm just going to make it sine x times 1 plus cosine x. On the bottom, these guys are conjugates, so the middle terms cancel. I've got 1 times 1 is 1. Middle terms will cancel, and the negative cosine times positive cosine is negative cosine squared x. We know from our Pythagorean theorems that 1 minus cosine x will. Trying to talk and write at the same time. 1 minus cosine squared x is the same thing as sine squared x. If you don't believe me, go check out the videos from section 5.1 and examples 1 and 2 from this 5.2. All right, so now one of these sine x's will cancel, and I'm actually going to need more room. I promise I'm going to try to give you more vertical room so you can give me a nice, good vertical proof tomorrow and on your test. All right, so here's where we're at right now. We're trying to get it up into 2 different pieces. So now that I've just got one singleton on the bottom, I'm going to split my top of my fraction up into 2 fractions. So 1 over sine x plus cosine x over sine x. Don't forget all your little equal signs here. All right, 1 over sine x would be cosecant x plus cosine over sine is cotangent x, and that is exactly where we were trying to get to. All right, for the U try, again, I see a fraction. If I have a single fraction, I have 2 fractions, I'll try to combine them. When we have single fractions, we're going to look in the denominator, see if there's something we can make a conjugate out of. The reason why making a conjugate helps us is the way it's written here, I don't have a squared, so I can't use that Pythagorean identity. But when we multiply by the conjugate, notice how we ended up with 1 minus cosine, and I could use the Pythagorean identity for that numerator or denominator. All right, same thing here. I've got tan x times secant x minus 1 in the numerator. The denominator conjugate, so secant x times secant x is secant squared x. My middle terms will cancel out, and then I've got 1 times negative 1, which is negative 1. Secant x secant squared x minus 1 from our Pythagorean identity is tan squared x. Canceling out one of those tangents, we get secant x plus 1 over tangent x. Now that I just have one term in the bottom, I can split this fraction up into 2 pieces. Secant x tan x plus 1 over tan x. So the second fraction is nice. We know 1 over tan x, I can get to, wow, this is minus. How did we get a positive all of a sudden? Here's a minus, sorry, minus. We can get to this minus cotangent x real easy because it's minus 1 over tangent. That's just the reciprocal identity. Secant x over tangent x takes a little bit more work. So secant x is 1 over cosine x. So let me just do it here. 1 over cosine x divided by tangent x, which is sine x over cosine x. Since I'm dividing a fraction by a fraction, remember you can keep the first fraction and flip it and multiply by the reciprocal of the second fraction. When we flip our second fraction and multiply it, notice the cosine x's will go away. And then I just have 1 over sine x. Sorry, they cancel out, and I've got 1 over sine x. That's cosecant x minus our cotangent x, and that's where we were trying to get to. All right, that's example number 3. I'll be back with example number 4 in just a minute.